Hi there. Today we're going to talk about Lesson 55. Lesson 55 has to do with average and rate problems with multiple steps. We know how to average numbers. We simply add them all together and we divide by the total number of numbers. Now, we can use this to do other types of problems. So let's pretend here. If the average of three numbers is 17, okay, and you're not told what the numbers are, what is their sum? Well, if they're all the same, meaning they're all 17, you could add 17 plus 17 plus 17 and you would get 51. Well, that's the number we're looking for. Their sum is 51. However, because you have to divide it by 3. However, you could also use 10, 11, and 30 and get 51 divided by 3 is 17. You could get 1, 1, and 49 and get 51 divided by 3, and that's 17. And it could be 16, 17, and 18. And if you add them together and divide them by 3, they're 17. So, the truth is of the matter is that the total number, really, that we're looking for, the answer, is simply 51. And we had it right away. All we had to do was take the average and multiply it by the number of numbers that we're supposed to have, for instance 3, and we knew what the number was right away. So that's pretty easy. Okay, so let's do it with 4 numbers. If the average of 4 numbers is 25, if we use the very same method that we just did, we could, without anything else, we could say, oh, well, if the average of 4 numbers is 25, we can just take 4 times 25, and that's 100. That's our sum. However, that's not exactly what we're looking for here. Close, but not exactly. If 3 of the numbers are 16, 26, and 30, oh, they gave us 3 of the numbers. Wonderful. Didn't give us the 4th one, though. What is the 4th number? Well, that's pretty easy. First, we find if all the numbers were the same, 25 times 4, it's 100. We have 16, 26, and 30. We're looking for the 4th number. So, probably makes sense. Let's just add what we have together. 16, 26, and 30. Replace that 4th number with n. So this is the missing number. This is the total. If all the 4 numbers were the same, it would be 100. Then we'll just solve it like a problem. 72 is the total of these 3 numbers together, plus the 4th number, which we don't know, equals 100. So then we subtract 72 from both sides and we get 28. So the 4th number is 28. That is the missing number. That's not hard. Okay, so here's another idea for using a missing number, or the idea of averages. If after 4 years the average number of students participating in activities was 89, after 4 years, how many students must participate in year 5 to bring the average up to 90? Now, I'm going to tell you right now, there's a lot of questions like this in homework that you have to do. So it's kind of a multi-step thing. The first thing, we need 2 numbers here. The first number we need is the total for 4 years if the average is 89. So to do that, we know we just take 4 times 89. That equals 356. Then we need the total for 5 years at 90. Well, 5 times 90 equals 450. Now what do you suppose we do with those? Well, if it was me, we just want to know the difference. What has he got to get that last year to make this total of 450 so that the average is 90? Well, sounds like an addition or subtraction problem to me. And that's what I think I would do. I would, to determine what number we need for the year 5, just subtract 356, which is the 4-year total, from the 5-year total, 450. When we do that, we get 94. So to have a 5-year average of 90, that last year we have to have 94 students participate. That's not bad. Not too hard. Okay, the very last thing we're going to talk about here is being smart consumers. When we go out to purchase things, sometimes we need to decide, are we getting taken on the price? Is that a good price? Are we paying too much at that price? You can use ratios to figure that out too. Okay? Now, this is also a multiple step problem, so you have to be patient with me. You got to write these things down. So we ask the question, which is the better buy? Is it the cranberry juice from brand X, 64 ounces for $3.20? Or is it brand Y, cranberry juice, 17 ounces for $1.19? Which is the better buy? Okay? So, I'm going to take a sticky here and I'm going to cover up the better buy because we want to figure out which one is the better buy, and I don't want to give it away right away. Okay, so this is the way we'll set up the first one. We have 64 ounces is $3.20. 1 ounce is X dollars and cents. So we go ahead and solve. We got to get the 64 out of here. We go 64 times X equals 320 times 1. 64X equals 320. Divide both sides by 64. You end up with a cost of 0.05 cents per ounce. Okay? Now we go down to the what seems to be cheaper purchase, and this is 17 ounces for $1.19. Again, we cross multiply. We end up with 17 times Y equals $1.19 times 1. 17Y equals $1.19. Put my little dollar sign there. Divide both sides by 17. You end up with 0.07 per fluid ounce. Now, take off the sticky and we can see that 0.07 per ounce is more expensive than 0.05 per ounce, and we note that with our inequality sign here. Okay, so 0.05 is less than 0.07, so it would be a better buy to buy 64 ounces for $3.20. And that's our last problem that we're going to talk about today. I hope that this was helpful for you, and we'll see you later in class.